HTTP is a first-class citizen in Node. In fact, Node started as a web server and evolved into the much more generalized framework it is today. Node's HTTP module is designed with streaming and low latency in mind. Node is today a very popular tool to create and run web servers. Let's look at the typical Hello World example for Node's HTTP module. We create a server using the HTTP module createServer method, which gives us, no surprise there, an event emitter object. That event emitter has many events, one of which is the request event, and this event happens every time a client connects to this HTTP server. It exposes a request object and a response object. We can use the response object to modify the response Node will be using for that request. In here, we respond with 200 OK, content type text, and the text hello world. The server runs on port 8000. When we run the script, Node will not exit because it has a listener handler and it will respond to any HTTP request on port 8000. If we inspect the headers this simple HTTP server is sending, we'll see HTTP 1.1. This is the current most recent version of HTTP that's supported in browsers. Response code is 200 OK, and the content type is what we set it to. And we have a connection keep alive and transfer encoding is chunked. Keep alive means that the connection to the web server will be persisted. The TCP connection will not be killed after a requester receives a response so that they can send multiple requests on the same connection. Transfer encoding chunked is used to send a variable length response text. It basically means that the response is being streamed. Node is okay with us sending partial chunked responses because the response object is a writable stream. There is no response length value being sent. After Node sends the 200 OK here, it can do many other things before terminating the response. And instead of inefficiently buffering everything it wants to write in memory and then write it at once, it can just stream parts of the response as they're ready. So this very simple HTTP server can be used, for example, to stream video files out of the box. But remember that the connection is not terminated here. So the browser knows that the content is done through the HTTP protocol. HTTP 1.1 has a way of terminating a message, and it's what happens when we use the response.end function. So if we actually don't use the end method, if we use the write method instead, in this case, when a client connects, they get the hello world, but the response is not terminated because basically Node is still streaming. In fact, in here, we can define a timer function. Let's make that fires after 1 second. And inside this function, we'll go ahead and write another message. And how about we write yet another message after 2 seconds? Let's try it. Run the server, connect, and you'll see hello world. After 1 second, you'll see another message. And after 2 seconds, you'll see the third message. And the server is still streaming. We have not instructed HTTP to terminate the response object. Let's make the timeout periods here a little bit longer. Let's do 10 seconds and 20 seconds and test that. Initiate an HTTP request. I see the hello world. Node is not really sleeping, it's just idling. It can actually handle other client requests during this idling phase, thanks to the event loop. Both of these requests are being handled concurrently with the same Node process. Please note, however, that terminating the response object with a call to the end method is not optional. You have to do it for every request. If you don't, the request will time out after the default timeout period, which is set to 2 minutes. As you can see, this write line did not happen because it's delayed to after the default server timeout. We can actually control the server timeout using the timeout property. So this line will make the timeout 1 second, and you'll see now how the server is going to time out right away.